Today we are approximating cube roots to the nearest tenth. Just like square roots, you should know your perfect cubes or refer to them on this notes sheet. Here are all the perfect cubes, well, the first ones for you, and you should know the cube root of 1 is going to be 1. Cube root of 8 is 2. Cube root of 27 is 3, because 3 times 3 times 3 is 27, and so on. Remember, we will not use the cube root button on our calculator except to check our approximations. The idea is that we can approximate this without having to use a calculator. And the process is the same as doing square roots, just you have to be careful that you're not using the same numbers as square roots because you want to find what will be the number that multiplies itself 3 times to get the number inside. So we're actually going to change this example, and I'm going to make it the cube root of 121. That 5 was like a typo, sorry about that. So we need to think of the numbers that are perfect cubes that are close to this because we know those are going to simplify to whole numbers. And I know 125 is a perfect cube that is close. So I'm going to go ahead and put that to the right. And the cube root of 125, if I check up here, is 5. Or you could just know. So then the other number that it's between will automatically be 4 because that's the integer less than 5. So we're going to put 64 up here because that is the one that simplifies to 4, right? Yep, right there. Okay. So now we know it's between 4 and 5. If your question asked which numbers is the cube root of 121 between, or which integers is it between, you'd be done. But we want the nearest tenth, so we need to find it to 1 decimal place. Now, every number between 4 and 5 will start with 4 point something. So I know it will be 4 point something. And let's figure out, I'm going to find out how far away 121 is from 64 and 125 to find out how far the cube root of 121 might be from each of those. So from 125 is really easy. It's 4 away. And from 64, you could put this in your calculator. You could subtract it by hand, but it is 57 away. And I actually did this one in my head. 124 is 60 away from 64, and then it's 3 less, so 57. Okay. There are 3 ways you can do this. One is you could just look at the numbers, and this one is actually pretty easy to do this. 4 is a lot smaller than 57. It is less than 1/10 of the size. And what I like about saying less than 1/10 is we can go, oh, that's going to be 4.9 something because 1/10 is 1 away, going to be a 0.9. So we can look at that and we can automatically know that it's 4.9. But you might want to visualize by using a number line. I'm going to just use 4 and 5 on my number line because I don't need any other numbers. And we're going to say that there are, these little red numbers are going to be like the dashes, and 121 is going to be the 57th dash out of 61 dashes. It's going to be 57 dashes away from 4 and 4 away from 5. Now, I don't want to draw 61 dashes. I'm really bad at it. But I'm going to draw 6 so that each one is worth like 10. Okay, and then if it's 4 little dashes away from 5, it's not even 1 whole dash away. It's like there. This is the cube root of 121. It's actually going to be not even right in between those 2 dashes. It's going to be closer to 5. Now, if you look at that, that is a lot of the ways over. It's here would be where our 4.5 is. So it's greater than 4.5. Here's where 3/4 would be, which is 4.75. So it's going to be like 4.9 something. And remember, we can check our answer at the end. You can know if you're right on all of these answers. Let's go ahead over here. I'm going to clear my screen and I'm going to put in the cube root of 121. Oh, excuse me. Yeah. And so I get 4.946, which rounds down to 4.9. And so look, I didn't even need my calculator for that. I got 4.9. Let's go ahead and do 2 and 4. Now 2 is a perfect cube root. If you look up here, 125 is up here. Ta-da! So we know it's going to be 5. This guy is negative, so we're just going to make it -5. Number 2 is super easy. If you have a perfect cube, don't even do the whole like find one below, find one above, just write what it is. Okay, we're going to do 4. And this one is negative. You could either try and think one below and one above, and with negatives, your numbers are going to be flip-flopped, or you can just say, you know what, I know that it's going to be the negative of whatever it gets when it's positive. So I'm actually going to find the cube root of 53 first and then just add a negative at the end. So let's find a perfect cube that is close to 53. I know 64 is, so it's bigger. So I'm going to put it on the right, and its cube root is 4. So the other number will automatically be 3, and it is 27. So we know this will be 3 point something because all numbers between 3 and 4 start off 3 point something. Now let's go ahead and see our distances. It is 11 away from 64, and it is 26 away from 27. Remember that you could put 53 minus 27 in your calculator. That's totally okay, or you could do it by hand like I'm about to show you. So that is 26. Awesome. So that's how you can find out those numbers. And looking at this, I know it's going to be bigger than 0.5 because these numbers are not the same. But it's kind of hard. These are kind of hard numbers for me to visualize. You could do the number line method. I'm going to show you doing it as a fraction and using like a simpler fraction to compare. So our numerator, remember, is the lower of the two numbers, the distance from the lower, and then our denominator is the total distance between the perfect cubes. So that would be 37. So it's like 26/37 of the way, and those are really ugly numbers. So I'm going to say that that's around like 30/40. We rounded both of them up, so it's going to be pretty close. And 30/40 is like 3/4, and 3/4 is kind of like 0.75. So I'm going to either choose 0.7 or 0.8, and I feel like 0.7 is good. So this is approximately what the cube root of 53 is. And we need the negative of that, remember? So I'm going to say it is about -3.7. Let's go ahead and check our answer. We're going to put the cube root, cube root of -53. -53, and I get -3.756. Now that would actually round up to -3.8, but remember -3.7 is really close, so this one is also acceptable. -3.7 is my final answer.